What do a wind turbine, an airplane, a kayak, and a car have in common? They all utilize composite materials consisting in a thermosetting matrix reinforced with fiberglass or carbon fibers. They combine mechanical strength with lightness, qualities that enable numerous industries to save energy and reduce emissions. Unfortunately, at the end of their life cycle, they generate a considerable amount of waste, and the raw materials raise issues of material sovereignty in Europe. The MC4 Project, supported by the European Union, brings together 16 partners from 8 countries. Its mission: to provide industrial solutions for the recycling of composites based on carbon and glass fibers, thereby enhancing European independence in terms of processes and materials while minimizing its environmental footprint. Every year worldwide, we produce 110,000 tons of composite parts based on carbon fibers and 4.5 million tons of composites based on glass fibers. The main components are largely manufactured outside of Europe, and when produced within Europe, technologies are often licensed from foreign countries. Their production is intricate. Manufacturing composites with carbon fibers generates nearly 40% waste. At the end of their life, whether it's after 1, 10, or 30 years of loyal service, only 2% is recycled. The rest is buried or incinerated. This issue will become increasingly significant with the retirement of an estimated 10,000 airplanes, tens of thousands of wind turbine blades, and hundreds of millions of cars by 2030. The MC4 Project is advancing 4 recycling processes that are not only technically feasible, but also economically viable at 2 distinct timescales: short-term and long-term readiness. Throughout the project, scientists are developing pilot products to showcase the effectiveness of these 4 recycling processes. Starting with the initial sorting machine, composite materials embark on a transformational path. They could then be crushed and reincorporated in new recycled composites. Waste during production can be cut into pieces to recreate new products. Another approach involves the creation of a new material, capable of being reshaped through heating. The final approach takes composites through a meticulous chemical treatment process. This transformative step allows the recovery of fibers transformed into textiles. The resulting quality is rigorously verified, ensuring the recreation of a composite. No fraction is left unutilized. Even the residue is carefully analyzed for potential revalorization. These circular value chains extend beyond presented applications, find practical utility in various markets, including civil engineering and urban furniture. Composite recycling is not only an environmental necessity, but also a step towards a more independent and competitive Europe. So who knows, perhaps in the near future, we'll be able to reconstruct airplanes, wind turbines, and cars using recycled materials.